Jai Hind all. I'm Dinanath Prasad, going to discuss a topic nuclear energy on the course of Power System 1. So, on brief, I will discuss basically nuclear power plant, what is nuclear power plant, how nuclear energy can be generated through the nuclear power plant, what are their component. Basically, I'm going to discuss in brief what are the layout of the nuclear energy, what are the advantages of nuclear energy, what are the disadvantages of using nuclear energy, and what are the site selections, how to in which site we select to use nuclear energy to generate the electricity. So coming out to this topic, so first of all, we have to understand what is nuclear energy, how nuclear power can be utilized for generating the electrical energy, how to generate the electricity from the nuclear energy. So basically, nuclear energy term is defined is the energy which is released during the two process, either due to the nuclear fission reactions or due to the nuclear fusion reactions, which is used to generate the electricity. So further, nuclear energy is the use of nuclear reactions. Nuclear reactions are the nuclear fission reactions and nuclear fusion reactions, which release nuclear energy to generate. Either we can use to heat, which is most frequently is that it used to steam turbine to produce the electricity. So basically, with the help of nuclear energy, we generate make nuclear energy as a source to generate the steam and further used to electricity to rotate the turbine. So this is the nuclear power can be obtained from the nuclear fission or nuclear decay, and it is the nuclear fusion reactions. These are the nuclear fission reactions which I have discussed in a later slide. So first of all, I will give you some introductions about what are the contributions of nuclear energy in India, particularly in India. So if we talk about nuclear energy, apart from the basic conventional energy source or non-conventional energy source like coal, gas, hydroelectricity and wind power, these are the some sources. If you comparing with the other sources, India nuclear power is the 5th largest source of electricity in India. So as of the March 2018, India has 22 nuclear reactor which is operated in nuclear power plant, 7 nuclear power plant, with the total installed capacity including nuclear power plant is around 6,780 megawatt of the capacity. This data that is 6,780 megawatt as of the data of 2018. So we having 22 nuclear reactor, but now in this time we can use only 7 nuclear power plant reactors as in operation stage. So these are the some data, these are the some power plant where we use nuclear reactor, that is in Kaiga, Kakrapar, Kundgum, Madras, Narora, Rajasthan. These are the some power stations through which we nuclear energy will be produced. Basically, nuclear power plant are the operated by the NPCIL. These are the state where these nuclear power plant are placed. These are the which types of nuclear reactor are being used on which place. These are the capacity. If you add, total capacity is around 6,700 or 6,680 megawatt. This is the capacity of nuclear power plant. So coming out the advantages, what are the advantages by using nuclear power plant? So these are the some advantages written here. The first one is it produces large amount of energy. It can produce very large amount of energy with the very small amount of nuclear fuel. This is the one of the major advantages. Space limitations, if we comparing with the other power plant, the space requirement is very less as comparing to the other conventional power plant. Another, this is nuclear power plant is a reliable source of energy, means we can definitely, if we use, we can produce electricity or heat any purpose. Another one is nuclear power plant produces a small volume of waste, although they have waste is very radioactive, they are very dangerous, but after all, after the using, the waste content of waste is very small by using nuclear power plant. And another one is they having low maintenance. Initial cost is however very high, but the maintenance cost or the service period of maintenance will be less in case of nuclear power plant. Now come to disadvantages of nuclear power plant or nuclear energy. Major disadvantage is the radiations. They create very harmful radiation to the environment, to our ecosystem, like the radiations may be alpha radiation, beta radiations, gamma radiation, that will be classified according to their content, how much the content of alpha, beta and gamma particles. Out of them, gamma is more dangerous to the health point of view comparing to alpha radiations and beta radiations. So this radiations part is very dangerous. That's why we are very careful, we take very careful consideration for the designing of any nuclear reactor and the choosing part of nuclear reactor. Another one is, this is non-renewable energy sources. Its non-renewable energy sources is itself is a disadvantages of any nuclear power plant. As we know, nuclear energy non-renewable means we cannot renew again and again. They can generate harmful gases to the environment, they can dangerous to our ecosystem. That's why these are the major disadvantages of the nuclear power plant. And another, if you talk about another disadvantage, it can be used for the developing nuclear weapons. Can some countries having more basically nuclear content elements are present on that areas on some countries. So some countries can be used in a different way for the developing nuclear weapons because they are very dangerous. So, and another one is the initial cost or the design of huge building cost will be very high in case of nuclear energy. Nuclear waste, in terms of nuclear waste, they are generating very low amount of nuclear waste, but this nuclear waste is very dangerous according to health point of view and according to the environment point of view. Nuclear power plant can create accident. Already this kind of accidents happens in the past, so we will very careful design and use of nuclear reactor will be very sensitive point of view. So this accidents is already happens in the past. So, and another one is the transport of fuel and waste. Although the unit of fuel from where we taken nuclear fuel or further disposal, they require very small amount, but we take very careful considerations for the transportation point of view and the fuel disposal point of view. So how we select the site for the nuclear power plant? So first of all, the major point is availability of water. What amount of availability water is required? If we comparing with the other power plant, the availability of water will be very high in case of nuclear power plant comparing to the other power plant like coal power plant. If we compare it with the coal power plant, although in coal-based power plant, we required large amount of fuel to cool down the steam, condense the steam, but the requirement of water will be very high in case of nuclear power plant. That's why any of the nuclear plant we choose, their water availability should be very high. Another one is disposal of waste. As we said earlier, the waste will be very dangerous. So nearby the power plant where we going to commission nuclear power plant, their waste disposal should be present, so that after the using a spent fuel, we can dispose on any area nearby the area. That can be dispose fuel that disposals can be done on onshore, or we can do in offshore, means they will be near to the power plant. Another one is they should have away from the populated area. As I said earlier, they can generate very dangerous radiations to the environment. There will be various accidents will already happen. So we taken care in any nuclear power plant should be very away from the populated area. Another one is nearest to the load center. Every plant requirement is the load center should be near to the power plant, but because of that, if we put very away from the load center, the transmission and distributions cost, the equipment cost will be included, means to reduce the this capital cost, we generally prefer to take any nuclear power plant or any power plant to the nearest to the load center. There will be other consideration factor, that is accessibility to the road. Road should be accessible. There will be rail facility. There will be, these are the general considerations while the designing of the nuclear power plant. Now coming up to very important term in nuclear power plant, that is nuclear fission reaction and nuclear fusion reaction. What are the difference between nuclear fission reaction and nuclear fusion reactions? How to generate heat, how to generate steam. This is the term by the nuclear fusion reactions or fission reactions. So this is the fusion reaction and fission reactions is the process, particularly if we talk about nuclear fusion reactions, where the smaller nuclear weight atoms are combined together and large amount of heat will be generated. If you talk about in general term what is nuclear fusion reaction, and in nuclear fusion reactions, heavier atoms will be broken down, and the correspondingly the large amount of heat will be generated. That is, the term is known as nuclear fusion reactions. So in nuclear power plant, nuclear fusion, or either will be doing nuclear fusion reactions, either we doing nuclear fission reactions, that will be done inside the nuclear core to generation for the heat, and further they can be converted to make steam, and that steam is used to rotate the turbine. Now coming up to difference in nuclear fission and nuclear fusion. In nuclear fission reaction, this break of heavy atom into two or more smaller one. In nuclear fusion reactions, it brings two or more small atom together to form a large one. It does not happen naturally. We can do nuclear fission reaction or we make chain reactions. Chain reactions is basically a small moving neutron we strike to the uranium material or nuclear material to break into the smaller ones, and through that we can generate through that this process they generated large amount of heat. And in case of nuclear fusion reaction, this is the natural process, and this is universally have a full of instance of nuclear fusion reactions. Every star using the produce the electricity. So, and another one is another difference from the nuclear fission and fusion, it produces great deal more energy than chemical reaction, but it is still not as much as fusion. In case of nuclear fusion, produces many times more amount of energy than the fission. So we can generate more amount of large amount of energy through the nuclear fusion reactions instead of nuclear fission reactions. Another one is it does not require lot of energy to split into atom into two. It requires lot of heat and pressure to process to happen. So this is the basic difference between the nuclear fusion reactions and nuclear fission reactions. Now come to nuclear reactor. What are the nuclear reactor? How nuclear reactor will be classified? What are the term and technology we will discuss here. So reactor basically we classified as a two types. They are either will be heterogeneous reactor or either they are homogeneous reactor. What are the difference between heterogeneous reactor and what will be the difference between homogeneous reactor is that in heterogeneous reactor basically a large number of fuel rod and the coolant is circulating around them and carrying away from the heat to release the nuclear fusion reactions. But in case of homogeneous reactions, the fuel and the moderator are mixed. Means in heterogeneous we take it at different we separate them in a different chamber, but in case of homogeneous we can make mixture of them, that is the homogeneous. Another one is we classified nuclear reactor, that is nuclear material, that is either we generally we use nuclear material as a natural uranium or we used enriched uranium. What is the difference between natural uranium and enriched uranium is that in case of enriched uranium the concentrations of uranium is somewhat higher than the natural uranium. How much higher? That percentage is around 0.71%. That 0.71% concentration will be higher in enriched uranium compared to the natural uranium. So natural uranium having 0.7% and its content increase up to the 90% in enriched uranium. Now come to moderator. We generally used water, that is the natural water, normal water. Then we used heavy water, that is the several gallon of water is combined to make a heavy water, or we can use as a graphite as a moderator. The life of the nuclear reactor will be higher of graphite comparing to the normal water or heavy water, because they possesses the corrosions in the nuclear reactor. We will discuss it further slide. So these are the basic essential component of nuclear reactor, that is reactor core, reflector, control mechanism, moderator, coolant, measuring instruments and the shielding. These are the there is many more instruments, but these 7 are the very essential component of the nuclear reactor. So we will discuss here the 7 component in a basic layout design of a nuclear reactor. So nuclear reactor, this is the basic design of nuclear reactor. You can see in this case with the diagram of a nuclear reactor. So you can see this is the part, outermost part. This should be very strong, so that the radiations can come out from the nuclear reactor. So this is outermost body. Some of the power plant are made of concrete material and some are using steel material. These are the based upon the designing of the design to the different nuclear reactor, so that the nuclear radiations cannot be come out from the outer world. This is the inside. This is called core. This is the core where basically 4 important term is used, that is the nuclear moderator, reactor moderator. There is a fuel, which kind of fuels are used. They are used some coolant and coolant we used. and another one we used as a control rod. So four things we installed or we put inside the core, put into the which place we put in a nuclear reactor, that is called the core. Another one is, you can see, shielding. Basically from the nuclear reactor there will be chain reactions inside the core happen. So during the nuclear chain reactions the radiations will be come out. These radiations will not come out to the outside world, so this will be some shielding material we use so that can reflect back into the core. So with this chain reactions or with this all component, basically large amount of heat will be generated. This heat will be transported to the heat exchanger. There is a mixture of heat and the water. Through the mixture of heat and water we generate the steam, and this steam is further fed to the turbine, and turbine will be rotated, and after that the turbine, there is a condensing unit, that is condenser we use. We again condense, and same condensed water we put into the heat exchanger. So this process is continuously in a cyclic way they will be running. So this is the basic layout of the nuclear reactor. If we discuss reactor core, this is the main part of the nuclear reactor which contain fissionable material, that is called nuclear fuel. The fission energy is liberated from the heat to operate the power and conversion equipment. The fuel element are made of a plate of rod of uranium. Another one is reactor reflector. This is the region surrounding the nuclear reactor core is known as reflector. Its function is to reflect back some of the neutron that leak out from the surface of the core, basically used as a protection devices. Now for the control rod, this is control rod is again put into the nuclear core. So the function of nuclear rod is to reduce the rate of reactions in a nuclear reactor, is controlled by the control rod. Since the neutrons are responsible for the progressions of chain reactions, suitable neutron absorber are required to control the rate of the reactance. So these are the some properties of control rod, that is for starting the reactor. It is used for maintaining at that level. It produces the steady state. It is used for shutting down the reactor under the normal or in case of emergency conditions. So basically we use two kind of control rod, that is either we use cadmium and the boron. So this cadmium boron are the material we generally use to as a control rod, that is slow down the chain reactions. Another one is moderator. The function of moderator is to slow down the fast neutron. Basically the neutron should be what temperature, what will be the conditions we maintain inside the chamber, inside the core. These are the moderator, what amount of heat will be generated. So the function of moderator is to slow down the fast neutron. What are the properties of moderator? It should have high slowing down power. It is the property that should be non-corrosiveness, high melting point for solid and low melting point for liquid. Chemical and radiation stability should have high thermal conductivity, abundance in pure form. The commonly used moderator are generally ordinary water, heavy water and the graphite. Now come to coolant. Basically inside of the core large amount of heat will be generated. To maintain the heat, to remove the heat, we use coolant. Another one is measuring instrument. So there is some kind of measuring instruments are used to maintain what will be the temperature, what will be the pressure, what is the inside condition. There will all are the basically the sensing instruments are designed to sense, and accordingly they are operated are all done by the measuring instruments. Now the shielding, this is the outer body of the nuclear reactor. The function of shielding is to it is based upon the design of different kind of nuclear reactor. So large steel recipient containing the core, the control rod and the heat transfer fluid. So this all components of the reactor are container in a solid concrete structure that guarantee further isolations from the external environment. This structure is made of concrete that having 1 meter thick, covered by the steel. These are the one of the design. Thank you for all.